Engineering Department at Istanbul Technical University and Deputy Director at the Istanbul Technical University Artificial Intelligence and Data Science Research and Application Center, ai.itu.edu.tr, as we say shortly. Thank you very much, everyone, for joining us today. I am really very excited about today's webinar because it is the first webinar held by ai.itu.ai. And I am also very excited for our guest today, Professor Lei Chen from Hong Kong University of Science and Technology. He is also director of the Big Data Institute at the university. On behalf of ai.itu.ai, thank you very much, Lei, for accepting our invitation. Before we start, I just want to let everyone to know that you can questions via YouTube chat, and at the end of the presentation, the last 10 minutes and so of this webinar, we kindly ask Professor Chen to answer several of these questions. A recorded version of this webinar will be available at our YouTube channel, and it is scheduled to last for about 40 minutes, including questions and answers. And we are going to try to keep it on time because our guest is joining us from Hong Kong, and we know that it is past 9 in the evening in Hong Kong. Professor Lei Chen, who will be giving us a presentation on human-powered AI today, holds a PhD degree in computer science at University of Waterloo. He's an IEEE fellow and ACM distinguished scientist. His research interests include data-driven machine learning, crowdsourcing-based data processing, uncertain and probabilistic databases, web data management, multimedia and time series databases, and privacy. Over to you, Lei.
Yeah, thank you for Shule's invitation. So, it should be good afternoon, right? Good afternoon, everyone.
Yeah.
So
good afternoon in Istanbul.
Yeah, I'm Lei. I'm from Hong Kong University Science Technology. Thanks for Shule's invitation. So, and we are colleagues when we both study in University of Waterloo. Time flies, right? Now around how many years? 20 years, right? 20 years
yeah.
ago.
A long time ago in a country far, far away.
Yeah. Okay, so today I'm going to talk about a very interesting topic called the data-driven and human-powered artificial intelligence. So this is our live talk. I cannot finish, but I will give all the stuffs like I can cover today. So AI is everywhere. So automatic planning, games, automatic control, diagnose, robotics, right? Many application fields like smart home, driving assistance, right? Recommendation, image recognitions, right? Personal assistant, right? Smart grids, everywhere. And actually the company like Google, Microsoft, Facebook are trying to their best, right? To try to say, I want to. So automatic plan be the frontier in AI, right? So like important shift from the mobile first world to AI first. And Facebook create Facebook AI research, the leader is very optimistic and they invested on the AI. So, a lot of top talent was hired by the Google and Facebook. Microsoft created AI research group. Others, IBM, Amazon, all put like Uber also have their own AI research lab, right? So in terms of government, so U.S. AI hold the potential to be the major driver of economic growth and social progress. You see like how America is afraid of China, right? They shut down their borders, let's say, scholar, Chinese scholars can come and, study or, whatever, say, in US or what they really free like technology will be, borrowed, whatever, by the Chinese scholar, but it's not true, right? And China have their own, education system. They educate a lot of AI talent. That's the reason China have released their domestic strategy plan to become world leader in AI. The same thing that Russia never want to be the loser, right? whoever become leader in AI will become the ruler of the world, right? This is Putin. So everybody is excited about AI. And actually, in the two years ago, in the Google Tech Forum, right? So the Pichai, the CEO of the Google, gave an amazing demo. Say like the personal assistant book a haircut via Siri. Oh, no, not Siri. We are like Google personal assistant, and then just book the haircut appointment without like the other end, like human receivers, like agent, knowing this is a computer or robot like trying to do a booking, right? So it's a lot of system. AI algorithm being used, like a recurrent neural network, Google's automatic speech recognition output by Google text-to-speech, and also they add a lot of data into the conversation to simulate humans, right? There's a demo there, and interesting people can find it like Google Pichai and 2018, demo. So in the domain of making appointments, actually it's past Turing test. I have to know what is Turing test, right? So that you cannot differentiate whether it's a human or the machine. But is that true? Like the potential of the benefits of AI are huge, and everybody amazing about the achievement of AI. Let's see an example. Everybody using Apple, right? So like iPhones. This is the demo I want to show.
Please tell me the time. It's 11:53 p.m. Siri, do not tell me the time. It's 11:53 p.m. I want to eat something spicy. Here's what I found. I want to eat something not spicy. Okay, here's what I found.
So you can see, this is Siri. How many AI talent being recruited by the Facebook, recruited by the Apple, right? iPhone and the Apple. See like they invest a lot on AI engineers, but their personal assistants still cannot differentiate not spicy, do not tell me time. Self-driving cars like Tesla, they always ask you to put both your hand on the wheels, even you are in automatic drive mode. What happens if you don't? That's accidents. So you can see, this. It's not like I'm giving a talk in in Istanbul University of Technologies that I use these examples. It is true, like Google Translate is showing the gender bias from Turkish to English, right? They always say like he is hardworking, she is lazy, he is pessimistic, she is optimistic. It's really, really gender bias. It's not good, right? So what is the current, what happening? So what is really current stage of AI? So this is 1950s, like people are really, amazing and feel excited about like a computer can play this very naive games, right? And they are so, wow, look at man, right? So happy about this computer can play this game. But what about advanced AI now? Say like this guy said, I have some very, very advanced robots, right? They said, wow, really? It's driven by deep learning and neural networks? Let's open it. Once you open the robot, you find a lot of if. This is current state of AI, right? So like, please tell me the time, right? Do not tell me the time because I do not have if, not time. Do not tell me the time. I only have if time. Tell me the time, right? That's the reason. So current AI cannot do this, right? So motivation of the talk of the work is like we feel big data and artificial intelligence and actual human intelligence should work together, not AI alone. So what happened? Say like AI before. Why suddenly AI become popular? So data actually determine the upper bound of AI. Previously, long time ago, when we studied computer science, we know this floppy disk, we know this hard disk. Like because we have limited storage, we cannot store all the data. So the data limitation limited the development of AI. So once the data have enough, we have enough label data, especially you see. So like with the increase of label data, you see a lot of AI algorithm like can achieve very good accuracy. Like this is CIFAR. Accuracy grows with the increase of the training data sets. And here that the training data set increase and is the accuracy increase, right? So what happens, say like other system with the big data, like intelligent system, like AI system. So question answer example, right? Say without like big data help, it's very difficult to use keyword search because people have keyword search and maybe they have typos, a variation in pronunciations, a lot of noise, and you cannot find the right answers. So it's really difficult to perform the reasoning on the data with high efficiency, right? See, we always make errors, but with the knowledge graph, like with the big data, you build that knowledge graph, then with this knowledge graph, easy to match noise mentioned in the entities because even you have typo because my knowledge graph have enough, accommodation for different, right? Enough redundancy to handle like different like typo or noise. So they can still help you find the answers, right? So it's easier to match those noise mentioned entities in the knowledge graph. And also because knowledge graph, you have an entity, you can do the inference, right? From the entities, you can inference a lot of the entity out. So you can do the reasoning, you can answer more, right? Who is Donald Trump? And then from knowledge graph, you find who is Donald Trump and who's his wife, his daughter, and then son-in-law. Every information piece has been there, so it's more comprehensive. So this is the world change, right? AI change since 2012. Before that, like AI cannot compete with human beings. After that, ImageNet come. Why did ImageNet change the world? Because a lot of data. You have a lot of data to do training. You have a lot of data to do the training the machines, and of course algorithms become deep and powerful. But before that, you don't have enough data. So the problem is like you will not compete with human beings. Now, suddenly, 2012, with ImageNet, you can see they achieve a jump accuracy 85%. And what else? And see like Facebook announced like deepfake, they achieve 97% of accuracy and beat human beings. And AlphaGo games, like you see, like they eat a lot, like the machine trained by so many old games, and then suddenly they beat human beings, right? So human is here. They are starting from scratch. AlphaGos, they learn everything's like 3,000 years. The old games in 3 days, right? So they learn all these games. So human actually will not be defeated by machine, right? They're starting to learn, adapt to new technologies. This is how the people starting to learn. They say, okay, you beat human. They're starting to learn from the computers. Say what kind of the strategy you use to win the game. So human is very clever, and also this is a machine have some. Say like decision making, right? You get some information using machine learning algorithms, get some guidance about recommendation, about decisions, and then you human finally learn from this to the final decisions, right? So the efforts of developing AI is not about replace human beings, but help, right? This is very important. You cannot say, oh, wait, say like AI will change our life, AI should replace human will be defeated by the AI. No. Look at this example. This is the Chinese to English translation, and it's a lot of English translation is good. A lot of English translation is bad. It's not bad. It's poor. Does not make any sense. So what they do, they use the human to do the translations, and human translations help to crack the barriers and also the improper orders, the grammars, and check, and then finally give you the perfect answers. And this is what this is. The envelope, right? The envelope have the address. You say, wow, this is easy. You give the AI enough data, and then you use OCR to train, and then you will recognize this character. But so far, it's really hard. Why? Because you don't have enough training images. You don't have enough ground truth. So what do people do? This is the ground truth. This is the facts. Right? The human was hired in the post office, reading from the envelope the address, and then try to recognize what's the character, what's the address, and put it into the computers. This is the state of art. This is the real life. Because AI does not have enough data, they cannot handle these cases because this human handwriting gets very, very rough, very, very difficult to recognize. So this is, I gave the example Syria, it's the NLP, natural language, speech recognition. I gave you example about this OCR. Now I give you another example what people really claim, be part of the AI, so like computer vision. So this is a forest fire. I've been using Google to search forest fire. And this is the result I got. It's not too bad. There's only 2 errors, right? The dinosaur and the fair hands. You will say, Lei, give me a break. Out of how many these images, like 15 images, only, 2 images bad. So the percentage wise is not too bad, right? That's, around 10, 15%, right? 10%. This error rate is not too bad. So, but think about this. It's not a tragedy if a neural network mislabel 1% of cats and dogs, right? It's 1% test dogs, then it's fine. But sometimes something like a self-driving cars or camera detection, this really, detection of couple line, the relations, even 1%, even 0.1%, do you feel safe, right? Nobody will feel safe. So this is give the challenge to the AI on short text understanding, not like semantic understanding, comprehension, and time-involved labels, and also high-level cost means like AI really need big data and humans help. This is example like really human help. In the ImageNet, it takes like 1 year, like around 1 million people's efforts to label the images. Manually and give the image label and what is it, confidence, and also the relationship between images. So this is human work. After human label this image, they can train machine become good object detector, the image labeler, right? So this is human help AI. First, they teach AI what is the object, what is car, and what is bounding box, and everything labeled by humans. So this is ImageNet, like 40 million images, like how many SenseNet, right? The nonsense is another ImageNet, right? So many categories. So my point is AI will not be succeed without big data and human intelligence. So how we can, make a story. So how AI really be succeed with the big data. So like AI and big data work together, right? The characteristic like the big data, like 4V, whatever we talk about, really, quickly overcome the capability of traditional analytics, right? So traditional we use decision tree, whatever, so frequent pattern mining. It's really, say like when the data become larger and larger, heterogeneous, and you cannot handle it. So, but AI at the same time need big data, right? So they need the label data, otherwise they cannot learn the knowledges. So big data and help AI. AI on the other hand, like using technology, algorithm structures, and everything's being developed, help to analyze the big data. So what I want to use an example saying, so big data is important for AI. So here's what we are working on, was knowledge extractions. Knowledge graph, using the big data, building knowledge graph. This is the gap. This is the bridge between big data and AI. So big data help build a very intelligent knowledge graph to answer questions, right? So how we can use the big data technology to help AI? So here I give a concrete cases of a knowledge graph construction, because once you construct the knowledge graph, it's becoming an intelligent agent to answer question answers, right? So this is the first directions, okay? So how we build this, how we use big data help AI. So there's, first, there are multiple sources, right? So there's a lot of sources you can retrieve the knowledges. Then after you retrieve the knowledge, what if the knowledge is ambiguity, is redundant, is error, right? So knowledge is wrong. How you do knowledge fusion. And after you have the knowledge graph being constructed, how you handle, say, like incomplete knowledge graph. Knowledge graph itself, obsoleted. And I also need some subjective knowledge, say like big cities, small cities, like a cute animal, all these things, right? So this is all the major tasks. Knowledge extractions, you track the knowledge from semi-structured data, and it's really hard. Why is hard? Because usually the knowledge graph, say like knowledge, you represented by these triples, like the subject, predicate, object. Say Obama was born in USA. So this is the knowledge, like knowledge triplets. We want to extract these knowledge triplets from the web pages, from discussion forums, all the unstructured data, even the Twitter messages, right? So basically, there's 3 types of knowledge extractions. Closed word means like you have rules. Closed IE align with the existing attributes, so they have some attribute, but extract new entities. You align the attribute because each entity have attributes. So the other things like open. So like I don't have the attributes can be free, and the entities is not limited. It's not limited by the existing entity or attribute. It's just free. So it's not like I already have in my mind, say like what kind of entity I want to extract, what kind of attribute I can represent these entities, right? So here I don't align anything. I say like open, so like you can extract any entity. Entity can have any number of attributes. So this is recent work we published in VLDB 2020 this year's. The idea is very simple. Okay, so we are extracting the knowledges from the free text. Okay, the first step, we do some pre-processing and knowledge extractions. After the knowledge extractions, right, after triple, we have the triple extractions. We want to remove the redundancy. We call it canonizations. After that, what's the major steps? We want to link this knowledge to existing one. So because we want to enhance the knowledge graph, right? There's some knowledge graph, there's some new messages come, new news come, new information, new technology, new concept. So based on all this situation, I want to map this concept to my existing knowledge graph. So that's the work, right? So that's what we call building a knowledge graph using the existing knowledges and then try to enhance the existing knowledge graph. So you think that this is easy, but think about it. This is the input. Michael Jordan and Kurt Miller study artificial intelligence. Jordan supervised blah, blah, blah. Let's see, there's something. Jordan supervised Miller in 2010, right? So this information, like Michael Jordan is a person, Kurt Miller is a person, artificial intelligence is a word, like is an objective, and 2010 is the timestamp. So after we do the calculation, right? So we find like Michael Jordan studying artificial intelligence, Kurt Miller studying artificial intelligence, and then so Michael Jordan supervised Kurt Miller. So as these three tuples. And with all these informations, we have to extract subset information. Why we want to extract set information? Look at this. Okay. So here, when you have this knowledge, you want to construct knowledge graph. It's like you want to put this, extract the entity information to the existing knowledge graph. You just suddenly found you have two Michael Jordan in your knowledge graph. One is basketball player, the other one is professor. Kurt Miller can be a baseball player, can be a new entity. So which one is the one you're looking for, right? You just have a context, right? Just one sentence. So you want to put this new knowledge like Michael Jordan study computer science, study artificial intelligence into the existing knowledge graph. But there are so many entity matchings. Which one is correct? So this is what we want to solve. We build a graph, use the set information. So other than the artificial intelligence supervisors, there are other informations can be extracted, so like set information, movie AI, and the movie is a CS branch, right? So all this information put together, we build a graph. This graph and use the similarity measure the two nodes, whether they're similar, right? Based on Michael Jordan is mentioned in the text, Michael Jordan in the entity in the knowledge graph, and Kurt Miller is a person, and artificial intelligence is either a movie or a CS branch. All these things map to knowledge graph. Now you build a graph. This is black one is a black edges show the black line show the edges between two entities. So with this graph, we want to find the dense graph. So why we want to find the dense graph? So dense graph satisfies the requirement of global coherence. Means that this similarity with this graph is largest, right? We want to find the similarity within this largest in order to satisfy needs. This is exactly the entity I'm looking for. Michael Jordan is a teacher, is not a basketball player. Okay, so finding this dense knowledge graph is really, really hard. So it's a MB hard problem. We reduce it to standard tree problem, and details can be found in papers. But the other things like if there are some confusion. So yeah, you have two dense graph, you don't know which one to pick. You can ask human to help determine the best subgraph pattern. But this is only in the cases there are some tie. You want to break tie. knowledge fusions, like this is even worse, difficult, because usually you extract information from web, right? So you want to build the AI, intelligent AI question answer engines. So here, like there are multiple facts, right? So like Mississippi rivers, like you have a lot of information give the length of Mississippi River, but they are not consistent. They are contradict to each other. They are not contradict. The value is different. So which one is correct? So there's different sources provide conflict facts. We want to discover truth information. So that's multiple truths, multi-domain expertise on assumptions, right? So this is the facts, like. So, and also there's some assumption, a piece of information like to be true is provided by many sources, right? A source reliability assumption, a source is reliable if it is provided by many pieces of truth information. So multiple truth assumption is there's more than one truth for each object. So like single truth and your birth date, your movies durations, right? Is single truth. Multiple truth, books author, right? So there's multiple author for the books. So movie directors, actors, okay? So there's also multiple domain experts assumptions. So source reliability can vary among different domains. For example, Albert Einstein is an expert in physics, but not on Earth, right? But a bookseller may provide abundant and process data, right? Very accurate data in art categories, but less or lower quality data on the science categories. So this is fact, right? So we did a lot of survey or investigating on different bookstores. We indeed found this is true, that different bookstores offer different, expertise on different domains. So I will not go through the details about how we find the ground truth, obviously, how we resolve the conflicts. Basic ideas is like we first find which domain this bookstore, whatever source offer in the richness in terms of the number of books, number of materials and textbook, movies offered by this source. Then after that, we say like whether there's a domain, correlated to each other. For example, in the action movie, always related with adventures, all these things. And also we do not treat the single answer, right? We treat the multiple truths exist. If you only provide the partial answer, we still treat this partial answer as a partial correctness, right? We consider the partial correctness using this formula. And then with this, and this, for example, then the last one, S4, is Tom Miller. As Tom Miller, if according to previous approach, you do not offer the whole answer, like you just go for 1/4 of the answer, right? Like there's 1/3, right? There's 3 authors. Then you only get 1, but previously just treated it as wrong, but here we treat it, no, it's partially correct. We give some credits. So this is how we try to find the truth discoveries. And then truth inference, we inference the truth based on the probability values claimed by the source, and also use the probability values as if this domains and the value is provided by this domain, and we give the probability as the probability that the value not claimed by the source may be false. So this is the truthfulness of the source. We give the credits and the calculated probabilities at the value offered by this source, whether it's true or not. With all this, with all the data, observations, and here, domain expertise, step 1, we already see. Step 2, confidence score of the values. Step 3, reliability. The source itself have the reliability. We put all this together using Bayes inference model. We can get which source is more, loyalty or have a high confidence be the truth, right? So the third topic is about construction knowledges. I'm still using the big data. So previously we used very simple example, just extract the facts from one struct test. What about this question answer? Like I want to know what is big city, what is cute animals, right? So movie by Christopher Nolan. This is easy. This is ground truth. But big city, what is big city? Unfortunately, and we have some data knowledge graph already have this big or small, we call the ST pair, right? Subject predicted, pairs. So with this pairs, right? And then we already know what it is. Subject knowledge being encoded in the knowledge graph. So Probase is a small core subjective database, but it's so small. It's here. It's only have 6,000 entities, right? Film have 8,000 films, like animals, 3,000 animals. All these things, I mean, say like because the coverage instance for each ST pair is very limited. So what we do is like we expand it, right? Expanded this knowledge graph to big knowledge graph with rich instance and properties. So we match ST pair. So this pair in the core subjective KB, DBpedia, Probase to the DBpedia. And then once we map it, so like in the Probase, they have what is big city, New York, San Diego, Chicago, right? So you think about it, all these cities share some common properties like area size, population, right? Can we use these objective properties to find a similar object in the large database and then infer which one is the big city? So this is our ideas, right? We want to use the properties and we find the, order of the properties. Like if you say the large city, the population must be over 10 million, okay? And then this is a lower bound. Then you found Beijing have 100 million. So, of course, like this is the big city, right? Because it's greater than the lower bound. So we found these partial orders and we use this partial order to identify which one is the big city with the cities already been labeled. Of course, whenever it's necessary, we refer to the crowd to ask crowd to label. And the question is like, you ask crowd to label which data here? Here, label. Like you use crowdsourcing to ask people to label some data. So you use crowdsourcing to label some data. So the question is like you ask a crowd to label which data. You cannot ask crowd to label every data. The only thing you can avoid, say like if I label the most influential entities, for example, this is the lower bound of my large city, and then the population size, area size, I label it is a big city. Then all the cities who have a larger population size, larger area size, all become large city. So you have to find the most important entity to label. It's not you label everything, right? It's not like label randomly. So this is, I will talk about later about how to select. So refinement, I will just pass it due to time limit. Is also the recent work using the embedding method. So how about artificial intelligence and human intelligence, right? So we talk about a little bit about it, like a large image data sets construction, we use human label. Why we use human label? Because ImageNet, about 10 million images using 1 year call labeling time, right? So 1 year, people label image one by one. It's really tedious job, and you have to really avoid the misconduct, right? Like some people just want to earn the money and then label the image freely and then randomly and then give you a lot of wrong images. So this is really, really important. So like how you can use human beings wisely. So this is an example. You put human in the loop about deep image processing. First, what? You ask the human to label some images, then you do the classifications. After do the classification, you find some unknown images. Then you put your unknown images to what? Back to the human. So that's the first. Human label images, then you put the image into different classes, use some classification models, and when the classification model trained, you're starting to use it and do the prediction. Of course, you cannot answer all the label all the images. There's some images they cannot understand. The machine cannot identify. They put this as a category unknown. That's been difficult for the machine. So you put back to this, human labels, a mechanical Turk or crowdsourcing, and then you ask them to do it again, and then they will refine and then come back. So this is called human in the loop. And you have 4 steps. First, label by human, do the classification training. And then after you do the training, you use this classification model to label more images. And the hard image will transport back to human to relabeling. Right, with 1% of human label efforts, and then accuracy, increased to 95%. So this is what we can claim. Put human in the loop, artificial and human intelligence work together to build the AI more robust. Okay? So here, I would say this is easy to say, right? How you can utilize human beings and you put human in the loop. And there's several things you have to consider. First, incentive design. We put human in the AI loop, ask human to label, ask human to help us to check data, ask human to do the AI process tuning and finally verify the results. So who is the king of this process? Human. So you're dealing with humans. The first, how you can motivate it. The second, I'm an expert I'm working on big data and artificial intelligence. If you ask me something about computer architecture, compiler, software engineer, I know it, I'm not good at it, right? So if you pass me some questions or some data or some labeling task related to this area, I cannot do it, right? So this is task selection. And also I have my expertise, I have my interest. I also have time zones, right? Now, if you send me some question after, say now it's almost 10, after 6 hours, say like 2 a.m. in Hong Kong time, asking me to do the labeling answers, of course, I'm not doing it, I'm sleeping, right? So this is the fact. So how you can assign the task to the right time, right position, to right people. And finally, human always make errors. Who will check, right? You ask human to check human, you accumulate errors. You ask the machine to check human, and how come the machine know the results, right? So this is the very, very funny things. Like you want to put human in the loop, you have to find like incentive, and you have to do the assignment, you have to verify the human. So starting from 2012, they're already starting working on these ideas. So the first is like how you can motivate the human. Of course, if you can motivate human, like work for you voluntarily, say like Wikipedia, take an overflow, that's good. Usually you don't, right? You use money. So once you use money, what are you afraid of? That the people will get money and run. This is the case. So in 2013, when we're 13, like we're starting these projects, and we found like we want to do some prediction with humans' help, with AI algorithm. We want to get more label data. We want to predict the 2014 as that the year is World Cup, I think. And then we say, we want to do the prediction. We get all the history data of the match, who is the winner, who is the best player, and all the games histories. And then we put into the AI machine engines, deep learning engine, but the result is not so good. We say, we miss one important factor, the fans, right? The football player, the fans, right? The fans of football, they always, give a very good suggestion, comments. They always have a good feeling about which team will win, who will the top player, who will be the champion. So we ask people on the Amazon Mechanic Turk, so can you predict who will be the champion? And if you predict, do this task, I give you, 10 cents, whatever, $1. And then immediately after release the questions, our money is gone, right? We somehow get $1,000 to do this, test. Then the $1,000 is gone within like 10 minutes. So fast. Everybody like come and answer question. Then we collect answers. I found like the people using China is the number one. Korea is number one. So all these people just get money. You know that China is not even qualified for the World Cup. And Korea, yes, they're good, but cannot be the champion. So people just want to get money. So this is really bad. So what we do next is that, we ask some stupid and naive question. How many players in a football game? How many goalkeepers? How many referees? How long each game? And what's the top player in Brazil team? What's the top player in Germany teams? Right? After all of these questions, you have the ground truth. You can verify whether they can answer the question correctly. At least you know they are the football fan, right? After that, I will say, you answer my question, 10 questions, all correct. Then you have $1. Now you use the $1 to predict who is the winner of 2014 World Cup. If your prediction is correct, it's matched to the majority of the prediction, I've given $2. If not, then you lose $1. Then suddenly you found that all the people, who try to answer this question, it's really slow down. It's like takes them quite some time to answer my question. The reason because they already have the credits, they don't want to lose their $1. They don't do the random work. They don't do the guess. They always ask others. Try to be very accurate. So the answer we collect is very good and high qualities. Actually, we did not lose any money. We just use the people who do the random work, who gets wrong, and use that money to pay for the people who really answer us correctly. So in this way, we control the human, we get good answers, we label data, we train our engine, and can do very good job. So this is how we utilize humans. Of course, there are some other things, like when you assign the job to human, how you measure the activeness, how you do the preference, how to do the expertise, right? So these things we model as 3 factors, maximization problems, and try to deliver the job to the right people at the right time. So last things like how to do verification. This is my dream. I want to put everything on the social media because social media is large and a lot of people can verify each other and they're doing things from bottom of their heart and they not get paid. They just do things because they feel that there's existence and they do this for fun. They do this, just for, the reputation, whatever. So it's without any payment they can do. I mean, say like people tweet on the Twitter, people leave notes on Facebook. Did they get paid? No, right? So this is the thing that if we can utilize social media, that's good. We can verify the answers. Other things like can we use machine? So if you have some human label image, like a scientific image, very good. Now you ask them to label some like, buildings, like scenery, pictures, or animal pictures. So how you can move this scientific labeler to the, animal, and label animals. So you have to have some machine learning to train these human beings, makes them really good. So this is called machine trained human label, right? So this is you have limited machine, you have limited labeled images and these domains. You want to train human being become the expert in these domains. So this is what I call DHA. Okay, basic ideas, right? So we want starting from here. Data cleaning, we get a lot of data. We use human to do the data preparation, do the data enrichment. After that, data is done enough. We put all the data inside of the engines and say, oh, this is the data. Human already label is not good enough. Then you have the cleaner method, the enriched data. So this data enrichment is always very important in the AI, right? You don't have enough label. People use GAN network, but before the GAN network, it still generates some human label data. Tell them that it's not enough, right? So enrich data in terms of people are doing this, like even the image classification use ResNet. The most important task is like you turn the image right upside down, turn it 360 degree, whatever. Like you change change the orders and you crop it and the center images, or you change the resolutions. All this called data enhancement, right? You put all this data enhancement, send to the human. Human now starting to do what? Labeling that this is animal, this is 2 animals, this is cats, this is dogs, and then humans do the annotations. You have to do the task assignment, you have to do the incentive. After the human give the results, what do? You train, right? After you train, you have the model, you do the model classifications, and then at the same time, what you do? Human do the assessment, whether the result is good, is not good. You tune the parameters, right? The parameters too large. The parameters are not accurate, then you change the learning rate, you change the layer, you change the batch size, and after this, and the model have learned something. The human starting to learn from models. For example, you learn how to label from scientific images to the animal images. So human learn how to the play strategy, like AlphaGo games, to be give, right? So human become the student. Anyway, human put here, and finally, human will be the end user, right? Do the refinement, do the verification, to tell people, wow, this is right one, this is correct one, this is not right one, right? Then you put all the result feedback to this, the data preparation and fulfill the loop. And at the same time, privacy should be protected, and also the quality should be controlled. So I will not go through these concrete examples. So this is my final slides. So what I want to do is here, the whole pictures until you see, when we build, say like give a concrete examples, when we build knowledge graph, we also use big data. So big data do the canonicalization, big data using knowledge fusion, big data do subject knowledge construction. This is 3 pieces of work I mentioned in my talks. And there are some other works like knowledge-based population with joint entity relation labeling, and also this negative sample generation also use big data together. I mean, this way, especially with the embedding techniques and the AI technology to help you build a AI intelligent question answer engine. And then when the people say, oh, your build the AI engine is not good enough, so we use say like crowdsourcing and the human intelligence to help it. So the final slide is like DHA, because DHA, data-driven human-powered machine learning. Why? Because big data, as I mentioned, I give a lot of examples, is critical for machine learning algorithm. Human can provide boosting the benefits, right? So I gave concrete examples, human label some images and boost the AI. So with this, I think big data, human, artificial intelligence should be combined together and build this very beautiful DHA domain. So we call it DHA is the fuel for next industry revolutions. Okay, so with that, I end my talk, and I hope human and machine can work together with the big data help, fulfill the dream of DHA. Okay, thank you. That's the end of my talk.
Okay. Thank you very much, Lei. Your research topics sound really interesting and extremely important. We now go to the questions. If you have a couple of time, do you have time for the questions?
Yes, go ahead.
Okay. The first question is, could you give an example which differentiate machine learning and artificial intelligence?
Yeah, that's good. I mean, usually because machine learning is like traditional machine learning, like decision tree, right? Decision tree and all these things like very, I mean, they don't need a lot of training data, and also the rules very clearly. For example, decision tree, you have these attributes, and they say like for example, your salary is higher than this, you go to left branch, and then your income, your how many children do you have? Then you go to these branches, and they've decided whether they will go give a loan or not, right? So this is very clearly machine learning. So basically, they have a model behind it, and the mathematical model, and then with the field training data, and you have built these decision trees, and then you can do the prediction. But for the AI, it's more broad. It's including machine learning, but it's more broad, means like deep learning. I mean, actually, they don't have some rules. They don't explain how it works. They say, okay, this is the layer by layer neural networks, and you give the data, and you feed in the data, then finally you can predict result. So here, you can also, let's say, backpropagation, gradient descent, and so many layers, and complete networks, and how many features. You use many features. Think about ResNet 50, like how many layers? 152 layers. And in terms of parameters, tuning parameters, 25 million parameters you have to tune. So think about this. And you don't give any, concrete decision or rules to explain how it works. So AI is more broad terms, like I think it's including, how the machine learning algorithm is also related, how the people label data and how the people use data, and finally how you verify, and also how to explain your result. The machine learning is more concrete on the algorithm and model design.
Okay, thank you. We have another question from Uğur Ali Kaplan. I guess it boils down to expecting a learning algorithm to work as reliable as a rule-based algorithm. Mathematically, machine learning algorithms will never be 100% error-free. So is autonomous driving doomed? This is a question from, I think he's a student of us.
So what's the exact question? So he want to know, so automatic driven is possible or not?
Yeah, no. Okay. Another question is how can we trust recommendations of artificial intelligence-based systems, especially when the knowledge learned by artificial intelligence is so noisy and biased?
Yes, good question. So that's the reason I said here, we always don't just rely on one thing here. So even my project is try to rely on a lot of things. So yes, AI algorithms say like the translation is biased and data is biased. Here, human, you always put human in the loop. Say human help. Say like you crack the answer, crack this recommendation. You cannot avoid even starting from the data collection. You collect some data on purpose, without bias. Otherwise, the machine do not know anything. Whatever the data you feed them, they will learn the rules. So when you find some bias or find some errors, of course, this is, they're never perfect, right? Starting from, like there's a lot of pre-trained models. After you have the pre-trained model, you have to feed some data to tune it towards your application. Sometimes like this model is good recommendation for, sportswears, but suddenly you say, oh, I want to use your model to recommend some tourist, packages, right? Tour packages. So going to somewhere to have a trip, right? A tour. And then you say like, this is a sports, this is tours. It seems not related. So how you can transfer this one to this one? So there's a lot of work like transfer learning, zero-shot learning, few-shot learning. You can use it. The question you ask, like there's bias, there's risky, there's uncertainty, incompleteness. Yes, this is imperfectness of AI. So we have to rely on human to help us to label more data, to crack it, and to make them more robust.
Okay, thank you. Another question is, so trustworthiness of a source is basically determined by majority. Is it possible to adversarially affect trustworthiness scores by bots? And it is also, he also said we could create many different accounts providing similar content in a topic, hence affecting the trustworthiness if we have enough resources.
Yeah, no, the problems like we cannot just only, this is related to the human labels, like of course also we cannot always trust the majorities. For example, Professor Şule, give an answer about big data, and a lot of students give answer about big data. Of course, I trust Professor Şule because she is the expert. So that means we have to rely on give the different weight for the expert compared with the normal users. So we have the weight, we have the reputation, we have the expertise. So our work, I suggest you read our papers here. Like these three factors, we have to check whether the workers, whether they're active, whether it's fit their expertise, whether their preference, right? So based on all these three factors, you can overcome the problems like, the majority answer is not always correct, right? And the other things you mentioned, like people hire somebody, like try to do this on purposely and misleading the facts. This can easily be found out because misleading facts, say like they are paid for answer. Of course, you're dealing with human beings. You can ask them to justify why you want to label this. Just give more answer, ask more questions. In these cases, you can find out whether they indeed answered the question correctly. Of course, when you collect answers, you find some ambiguities. These authors, like these things here, the workers, whether they are expert in this area, whether they always answer these questions, their activeness, you can easily find out like a lot of people never answer this question, suddenly come to answer this question because they are being paid to answer this question, right? So their answer is not correct. We don't believe it. So we can filter a lot of people who are biased to do these bad things, and we can remove them. So this is a lot of works, like you can check my papers. we have some works on this, like how to differentiate people like being paid, or how can treat the like authors or workers are reliable and truthful answers. Yes.
Okay, thank you. Another question is for knowledge extraction, what is the optimal graph database design? Are traditional ones able to handle a complex design as you shown?
Graph databases like knowledge graph, actually we use RDF and it's good enough to store them. But whether we use a graph, specified graph database to store this knowledge graph is very, very good question, because now we use these triplets to store them. It's kind of a native graph database. Whether we use relation data to store them, of course, that costs a lot of join operation. I mean, say like you have to join a lot of triples, like Lei teach in UST, Lei's friend, and with Tamara work in Waterloo, Lei graduate in Waterloo. All these things, like you have to join together to get a whole picture. Lei's supervisor is Professor Tim also, right? So in these cases, like you have to join many triplets. So you have, join operation in the database is very expensive. So maybe at the moment, so better you store your knowledge graph in a graph database, and then it's easy for you to answer various questions. Who is the supervisor of Lei? Where Lei study? And where is the University of Waterloo? All these questions can be easily grabbed as, twig queries, like small edge queries in the graph. Yeah, I think better you store in a graph database. And there are so many graph databases you can use. And RDF is one of the graph formats you can store knowledge graph.
Okay, thank you. And another question is detecting the unknown category or the wrong output is another challenge on its own. Neural network models do not readily output the confidence in its outputs. Did you work on that or any thoughts for that?
Yeah, like this depends on how you output, right? So like you can output the categories like with the confidence. This is, you can always change the softmax functions. Instead of output 0, 1, you can output some confidence, uncertainty, and that's easy to modify the last layers and output some confidence, like whether it is 1, what's the confidence, whether it's 0, what is confidence, and if you find like a 1 or 0 confidence is 50, you can treat this as unknown. So this depends on how you can modify last layer. Is who said the neural network can only output 0 and 1, and you can always give the confidence to the last layers and output some confidence of the result. Yeah.
Okay, thank you. And the last question is for someone just getting started in artificial intelligence, where would you suggest I start off as an engineer?
Start off what?
As an engineer. A starting point working in this field, for example. What is the best resource for people who want to start working in this field?
Best resource in terms of the book or in terms of class? Or
yeah, I think so. In terms of a book, maybe in terms of some courses.
Actually, I think the most important things that you have to study is statistics. Right? If you really started from, you want to build some beginning, the foundation, and the statistics important, and also the data mining courses, statistics, and also basic machine learning courses. For example, you learn something, what is the neural networks, what is deep learning, and other than that, I think deep data mining, statistic, artificial and deep learning networks, and they pick up one topic that you are interested, for example, CV, computer vision, NLP, and do some research work on that. That will be. But if you just want to work in industry, I think one statistic, data mining, machine learning, and it's good enough. And then you have to do some project using PyTorch or TensorFlow. then get you has 30, then you know how it works, right? Say like what is backpropagation, what is auto differentiation, what is the tensor layers, what is a tensor, all these things, right? Say like you have to really do some projects and know what is exactly going on for the deep learning network.
Okay, thank you very much. And I will kindly ask Lei, maybe if you want to say any final remarks or anything you want to say before we close the webinar.
Yeah, actually, I appreciated the chance and really hope here. This picture gave you, some ideas, the slogan and what I want to see. So we cannot just work on AI. We cannot just work on big data. Actually, we hope people get the idea. Human is always the king. Human is not going to replace by AI. We are still dominating the world. AI only help us. We will make the technology right, work for us, and not like the technology replace us.
Yeah. Thank you, Lei, for your excellent presentation today. And thanks to all of you for joining us. We will continue our webinars next month. And so stay tuned for the next activities of I2U AI and stay safe and healthy. Thank you very much again.
Thank you.